Hello students, welcome to MAGESH classes. In this presentation, we are going to discuss about 11th chemistry unit number 9, book back questions in detail. Shall we move to the question part? The first one, the molality of a solution containing 1.8 gram of glucose dissolved in 250 gram of water. Concentrations are expressed in various terms, molarity, normality, etc. The molality is among one. The molality is represented as small m. It is defined as the number of moles of solid upon the weight of the solvent in kg. In this problem, it is given that the 1.8 gram of the glucose, it is a solute. So it is a number of moles of the solute. So mathematically, it is N2 divided by W1 in kg. N2 is nothing, it is number of moles of the solute. It is W2 by M2. By substituting, you can write the M is, the molality is equal to W2, it is the weight of the solute, divided by M2. So this combination is N2, and the weight of the solvent, it is W1 in kg. So this is the basic equation you have to know. Okay. Similarly, you can write the molarity is equal to W2 by M2 into B1, the volume of the solution in liter. So this is the difference. In this manner, you can write N is equal to W2 divided by, instead of molecular mass, you have to write equivalent weight into volume in liter. So molarity, normality are the basic equations of this one. Students, you have to remember this, and you can solve any problem using this formula. Here the molality. So what is molality? M is equal to the W2, it is the weight of the solute, 1.8, divided by M2. M2 is the molecular mass of the glucose. Glucose formula C6H12O6, carbon 12 and hydrogen 1, oxygen, the atomic mass is 16. So 6 into 12 plus 12 into 1 plus 6 into 16, it is 180. So molecular mass of the glucose is 180 into, it is 250 gram of water. 250 gram of water is equal to, it is 0.25 kg, clear? Or 250 divided by 100. So it is 0.25. So this is equal to 1 by 100 into 0.25. So this is equal to 1 by 25. This is equal to 0.04. Okay, your answer is D. Students, you have to keep in mind the molality formula, molarity, normality in such a way. So in kg, or it is divided by 1000, okay, or in this case liter, or divided by. Question number 2. Which of the following concentration terms are independent of the temperature? Molality, mole fraction, and option A and C are given. So we have clearly discussed in the previous question. The molality is equal to number of moles of solute N2 divided by weight of the solvent in kg. Okay, this is molality. And molarity, it is capital M, it is given as the number of moles of solute divided by volume of the solution in liter. And normality, the equivalent, number of equivalent is calculated. And mole fraction, you know that the mole fraction of the any species is equal to number of moles of X in the combination, that is total moles. So it is mole fraction. Mole fraction, the factor is W divided by molecular. So these are in the gram. So only the terms involves volume times or molarity. So any terms which involve the volume of the solutions depends upon the temperature. Because by raising temperature or lowering temperature, the volume is changed and so the molarity also changed. So similarly, normality terms also involved in the volume terms. So it also depends upon the temperature. But in case of molarity, there is no volume term, only the kg, kilogram and gram terms are there. So in case of mole fraction, only the gram terms are there. There is no volume term. So it is independent of temperature is molarity, that is A, and mole fraction. Your answer is D. Question number 3. The stomach acid, a dilute solution of HCl, can be neutralized by the reaction with aluminum hydroxide. So this is a chemical reactions when the aluminum hydroxide is added into the stomach acid. So in form of aluminum gel, when it is taken, it reacts with the hydrochloric acid present in the stomach. So this is a reaction. How many milliliters of 0.1 m aluminum hydroxide solutions are needed to neutralize 21 ml of the 0.1 m HCl? So what is the amount of the aluminum hydroxide needed to neutralize this 21 ml of the 0.1 m HCl? For that, let me write the neutralization reaction once again. That is aluminum hydroxide with 3 molecules of HCl, moles of HCl, to give aluminum chloride and 3 moles of water. So in the neutralization, we have to know the formula V1N1 is equal to V2N2. V1 is the volume of the first species and N1 is the volume of the, N1 is the normality of the first species. Here the given data are aluminum hydroxide molality is given, that is 0.1 m aluminum hydroxide, 0.1 m hydrochloric acid, and the volume of the hydrochloric acid is taken as V2, it is 21 ml. The volume of the aluminum hydroxide is in the question. The concentration is given in the molarity, so you have to convert into normality. The relation is the normality is equal to molarity into basicity of the acid or acidity of the, or number of replaceable H plus ion or OH ions. So this is 10. So in case of aluminum hydroxide, it has 3 replaceable OH ions. So the normality is equal to molarity is 0.1 and into 3. So normality is equal to 0.3. In case of hydrochloric acid, the replaceable H plus is 1. So the molarity is equal to 1 into 0.1. This is equal to 0.1 n. By substituting this value, so V1 is volume of the aluminum hydroxide. This is in the question, and in the volume of the normality of the aluminum hydroxide is 0.3 is equal to V2, it is 21, and N2 it is 0.1. So V1 is equal to, that is volume of the aluminum hydroxide needed is 21 into 0.1 divided by 0.3. So this can be cancelled as 3. So 21, 7 21s. So this is equal to 7 ml. Your answer is B. Question number 4. The partial pressure of nitrogen in air is 0.76 atmospheric pressure and its Henry's law is constant 7.6 into 10 power 4 atmospheric at 300 Kelvin. What is the mole fraction of the nitrogen gas in the solutions obtained when the air is coupled with the water at 300 Kelvin? It is a very easy relations. The partial pressure of the gas is given as, the partial pressure of nitrogen is given as the Henry law constant, that is constant Henry into this mole fraction. So this is a basic relation. So partial pressure is equal to this Henry constant into mole fraction. So the problem, the partial pressure is given. Okay. What is the partial pressure? It is 0.76 atmosphere. And the Henry's law constant also given, it is 7.6 into 10 power 4 atmosphere at constant temperature in Kelvin. And the mole fraction of the nitrogen gas is the question. So mole fraction is equal to 0.76 divided by 7.6 into 10 power 4 atm. Here the atmosphere cancel, unit is cancelled. So mole fraction, no unit, it is merely number. By cancelling you get it is 0.76, it is 7.6 added to 10 times. So this is equal to 1 divided by 10 power 5, we can write. So this is equal to 1 into 10 to the power of minus 5, no unit. Your answer is D. Question number 5. The Henry's law constant for the solubility of nitrogen gas in water at 350 Kelvin is 8 into 10 power 4 atmosphere. The mole fraction of nitrogen in air is 0.5. The number of moles of nitrogen from air dissolved in 10 moles of water at 350 Kelvin and 4 atmospheric pressure. This problem consists of two cases. One is the mole fraction of nitrogen in air. Mole fraction of nitrogen in air is given 0.5. The partial pressure of gas is related to the mole fraction by two ways. That is the Henry law's constant into mole fraction. So this is in the case of solution. Partial pressure of any gas is equal to total pressure into mole fraction. So this is in the gaseous condition. In the gaseous condition, the partial pressure and the total pressure is given. So by using this gaseous relation, the partial pressure of nitrogen is equal to total pressure, it is 4, and the mole fraction is 5 in the gaseous condition. So this is equal to 2 atmospheric pressure, that is partial pressure of nitrogen. By knowing this partial pressure of nitrogen and apply this partial pressure in the liquid condition. So 2 atm, the partial pressure is equal to, the kH is given, it is 8 into 10 to the power of 4 into mole fraction. Mole fraction is nothing, it is the number of moles of nitrogen divided by total moles. In this problem, the number of moles of nitrogen from air dissolved in the 10 moles of water. So the number of moles of nitrogen is in the question. Let the number of moles of nitrogen be X. By taking the number of moles of nitrogen X, the equation will be 2 is equal to 8 power 8 into 10 power of 4 into X by 10 pluses. We are going to solve the X value. We can write X by 10 plus X is equal to 2 into 10 power minus 4 divided by 8. So 8 into 10 power, it will be minus 4. Or 10 plus X by X is equal to 8 into 10 power 4 divided by 2. This will be 10 plus X upon X is equal to 4 into 10 to the power of 4. So this is equal to 40,000. Here the 10 plus X will be 10 by X plus X by X. So it will be 10 by X plus 1 is equal to 40,000. Otherwise, the 10 by X is equal to 39,999. So by minus 1. So taking as a 40,000, the X is equal to 10 divided by this 39,999. I'm going to say it is 40. So this is equal to 1 by 4 into 10 to the power of 10 by 4 into 10 to the power of 4. Okay. So this will be 2.5 into 10 to the power of minus 5. Minus 4. Clear? Question number 6. Which one of the following is incorrect for ideal solution? For an ideal solution, the mixing is the entropy change of mixing is not equal to 0. That is, entropy increases or decreases, and del G mixing is not equal to 0. For an ideal solution in the case of mixing, del V is equal to 0. Del H enthalpy change is also 0. And internal energy change that of mixing is 0. And del P, that is partial lowering of vapor pressure, is equal to P naught minus P is also a 0. Because ideal solutions obeys Rolle's law. So these terms are 0 for the ideal solution when mixing takes place. Only the variable is entropy and free energy. The question, which one of the following is incorrect for ideal solution? So del H of mixing is equal to 0. Correct statement, the internal energy change, that is U or E, it is 0. And del P is equal to P absorbed minus B calculated is equal to 0. And del G of mixing del G is not equal to 0. The 0 is given, so this is the incorrect statement. Your option is D. Question number 7. Which one of the following gases has the lowest value of Henry's law constant? Henry's law constant depends upon the nature of the gaseous solute and solvent. And KH is defined as partial pressure of the gas divided by mole fraction. When lower is the partial pressure, KH is lower. It is directly proportional. So partial pressure is lower and the gas is lower. So when you dissolve the nitrogen, helium, carbon dioxide and hydrogen, it is highly soluble in water. And so the partial pressure of the carbon dioxide is very low when compared to the other one. So that by substituting the partial pressure of carbon dioxide in this case, as it is low partial pressure in the solution when it is dissolved in water, so it has least KH value. On the other hand, the most stable gas has lowest KH value. So partial pressure carbon dioxide is lower and also it is more stable. So there are two factors which affect this KH value. So the answer is it is more stable when compared to the other, and it shows low partial pressure in the system. So the relation indicates that lower is the partial pressure, lower is the KH. Your answer is carbon dioxide. Question number 8. The P1 and the P2 are the vapor pressure of the pure solvent, pure liquid components 1 and 2. The binary solution, if X1 represents the mole fraction of the component 1 and the total pressure of the solution formed by 1 and 2. So in the components, the P1 is the vapor pressure of the solvent 1 and P2 is the vapor pressure of the solvent 2. And the X1 component is the dissolved in the solution P1 X1 and here the X2. We know that the total pressure is equal to P1 into X1 plus P2 into X2. There are two gaseous system present in this case. So it is a mole fraction into partial pressure of the component 1, mole fraction into partial pressure of the component 2 is equal to total pressure. So we know that in the equation, total pressure is equal to mole fraction. We know that partial pressure is equal to mole fraction into total pressure. And one more equation, that is the mole fraction of the component 1 plus component 2 is equal to 1 for the any solution, binary solution. So we can write that this P1 is equal to P1 into 1 minus X2 plus P2 into X2. So that X1 is eliminated. It is a total pressure. Or it is P1 minus Px2 plus P2 X2 is equal to P. The X2 is common, so it is P1 minus X2 into P1 minus P2. This is equal to P. So this expression is present in the option C. Okay. Question number 9. The osmotic pressure of the solution is given by the relation. The osmotic pressure is directly proportional to concentration. As concentration increases, osmotic pressure increases. And the pi is directly proportional to temperature. So the osmotic pressure is directly proportional to concentration and temperature. And this is equal to the gas constant R is introduced. And this concentration is nothing, the pi is equal to the number of, it is in the concentration of molar, so it is N by V into RT. Or it is equal to pi into V is equal to N RT. Osmotic pressure directly proportional to concentration and temperature. To remove the proportionality, the constant R is introduced. The concentration is in molarity, so it is N by V. So cross multiplication pi into V is equal to nRT. Your answer is B. Question number 10. Which one of the following binary liquid mixtures exhibit positive deviation from Raoult's law? The deviation, either positive or the negative deviation, depends upon the intermolecular attractive forces of the mixture. That is acetone and chloroform, water and nitric acid, hydrochloric acid and water, ethanol and water. If the internuclear attractive force between the two liquid is less than that of the intermolecular force among themselves, then it is positive deviation. The intermolecular force of A and B are the two liquids is less than that of A in AA or the B in BB. It is said to be positive deviation. So it is less, it is called a positive deviation. The case 2, suppose the intermolecular force is greater than this A in AA, B in BB. Now it is negative deviation. The question is, which among the following exhibit positive deviation from Raoult's law? So in the experimentally, according to experimental evidence, the answer is D. Now what is our explanation? Ethanol is easily evaporated. As a result, the vapor pressure of the solution is greater. Vapor pressure of the solution is greater due to the evaporation of the ethanol. Similarly, the interaction between water is also greater than that of the interaction between ethanol and water. So it shows positive deviation. Your answer is D. In addition to that, the mixing of these liquids in positive deviation, the delta H is greater than 0. That is endothermic process. Question number 11. The Henry's last constant for two gases A and B are X and Y respectively. The ratio of the mole fractions of A to B is 0.2. The ratio of the mole fraction of B to A dissolved in water will be. The Henry's law constant of A is X and Henry law constant B is Y. So partial pressure of A is equal to X into mole fraction of A. Partial pressure of B is equal to Y into mole fraction of B. Given that the ratio of the X of A, mole fraction of A to mole fraction of B is equal to 0.2. The question is, the mole fraction of B to A is in the question. Mole fraction of B to A can be written as partial pressure of B upon partial pressure of A into X upon Y. It is a Henry law constant for the gas A and it is Henry's law constant on the Y. So it is an inversion. That is, mole fraction is equal to partial pressure divided by the Henry's constant. So it is in the inverse case. The partial pressure of B is proportional to the mole fraction of B, and the partial pressure of A is related to the mole fraction of A. So we can write the x of B upon x of A is equal to reverse of this 1 by 0.2 into x upon y. So this is equal to 0.2y here x by multiplied by 5. This will be 5x here y. So the answer is D. Question number 12. At 100 degrees Celsius, the vapor pressure of a solution containing 6.5 gram of a solid in 100 gram of water is 732 millimeter of mercury. If Kb is equal to 0.52, the boiling point of the solution will be. As we know that the boiling point of the solution is greater than that of the boiling point of the pure solvent. The del Tp, the change in temperature, change in boiling point is equal to Kb. It is a ebullioscopic constant into M. The given problem, the W2, that is solute is, weight of the solute is given. This W2 is 6.5 gram. And weight of the solvent, it is given, it is 100 gram. The vapor pressure of the solution is given, that is 732 millimeter of mercury. So what is the boiling point of the solution? So we know that to find out the molecular mass of the solute, we have start with this relation. Del P by P naught is equal to N2 by N1. By expanding, this will be W2 by M2 into M1 by W1 del P. Del P is nothing, the 760 millimeter of mercury minus 732, this is the difference, divided by 760. So this will be 28 divided by 760, this is equal to W2 is given 6.5 and M2 it is unknown, and M1 it is molecular mass of the water, it is 18, and W1 100 gram. Okay. From that the M2 is calculated. It is equal to 760 into 6.5 into 18 divided by 28 into 100. By solving this, you get M2 is equal to 31.75 gram. Okay. If M2 is known, you can calculate the del Tp, that is change in temperature of the solvent and solution is known. So the Kb is given, Kb is 0.52, and in place of molality you can write number of moles of the solute divided by weight of the solvent in kg. Okay. So by expanding this, del Tp is equal to 0.52 into N2 is expanded as W2 divided by M2 into W1 in kg. By substituting, del Tp is equal to 0.52 into W2 is 6.5 and M2 we have calculated 31.75 into W1 in kg, it is 0.1 kg. Okay. So this is equal to the 6.5 and is cancelled. It is 5 times 5 into 5 is 0.5. So 0.52 divided by 0.5. This will be 1.06. Delta Tp is 1.06 Kelvin. So delta Tp is equal to T minus T0. Here the question is boiling point of the solution. So T is equal to del Tp plus T0. So 1.010 plus 100 boiling point of water. So this is equal to 100 not 1 degree Celsius. Your answer is C. Question number 13. According to Rolle's law, the relative lowering of vapor pressure for a solution is equal to. Raoult's law is nothing. Mathematically, it is relative lowering of vapor pressure is equal to mole fraction of the solute. So X2 is nothing. It is ratio of the number of moles of solute to the total number of moles of solution. So your answer is mole fraction of the solute, B. Question number 14. At the same temperature, which pair of the following solutions are isotonic? Isotonic solutions having same osmotic pressure. For a solution, pi 1 is equal to C1 RT is the first solution, and the second solution is having pi 2 C2 RT. If it is same osmotic pressure, then it is pi 1 is equal to pi 2. That is C1 RT is equal to C2 RT. RT is constant, so C1 is equal to C2. So for isotonic solution, concentration of the first solution is equal to concentration of the second one in the molarity. See here that it is 0.2 m barium chloride and 0.2 m urea. It is non-electrolyte. But in the case of 0.2 m barium chloride, it dissociates to give 3 ions. So this combination may not be isotonic. Here it is 0.1 m glucose, it is 0.2 m urea. Both are electrolyte, but number of ions are concentration is different. Similarly, it is 0.21 m NaCl and it is 0.1 m potassium sulfate. It gives 3 ions, it gives 2 ions. So it is different. Here the 0.1 m barium nitrate and 0.1 m sodium sulfate, both are having same concentration. Here the number of ions are 3. Barium nitrate dissociate to give 2 nitrate ion and 1 barium ions. So it gives 3 ions. Similarly, the sodium sulfate also dissociate to give 2 Na plus ion and 1 sulfate ion. So it also gives 3 ions and same concentration. So this is your answer, isotonic solution. The empirical formula of a non-electrolyte X is CH2O. A solution containing 6 grams of X exceeds the same osmotic pressure as that of 0.025 m glucose solution at the same temperature. The molecular formula of the X. To find out the molecular formula from the empirical formula, the molecular weight should be known. So from that you can convert the empirical formula into molecular formula. So in the first step, you find the molecular mass of the X, and the second step, conversion of the empirical formula to molecular formula. From the formula it is given that the empirical formula CH2O and the weight of the substance X is 6 grams. We know that osmotic pressure is same. It is said to be isotonic solution. So pi 1 is equal to C1 RT. Similarly, the pi 2 is equal to C2 RT. For isotonic solution, pi 1 is equal to pi 2, or the C1 is equal to C2. C2 is nothing. It is the number of moles of solute, number of moles of the first substance. C1 is equal to C2, or it is molar concentration N2 by V is equal to N2 by V for the first substance. It is the second substance. V is constant, so it is W2 by M2. Here it is W2 by M2 of the first one, and it is the second one. By substituting, you get a molecular mass of this species. What is W2? It is 6 grams. 6 grams of what? A solution of 6 grams of X. So the molecular mass of this is M2. Okay. And the same osmotic pressure of the another solution is glucose. Glucose concentration is 0.025. So putting this 0.025 here. So instead of glucose. So what is M2? M2 is equal to this 6 divided by 0.025. This is equal to, this is equal to 6 divided by 25 into 10 to the power of minus 3. This is equal to 600 divided by 25. This is equal to 240. So molecular mass is 240. Then N is equal to molecular mass divided by empirical formula mass, that is 240 divided by the empirical formula mass is 12 plus 2 plus 16, it is 30. So 8, N is equal to 8. Molecular formula is equal to empirical formula into N. So empirical formula is given, that is CH2O, N is 8. So the formula is C8H16O8. The answer is B. Okay. So in this problem, the empirical formula and weight of one solute in the solution is given. It is isotonic with 0.025 m glucose. Empirical formula to molecular formula, you have to find out the molecular mass. The molecular mass is obtained by this isotonic relation concept. From the molecular mass, the n, the ratio is find out. Molecular mass, molecular formula is equal to empirical formula to n. Okay. So this is the end of the presentation. So I hope that it is useful for you. Thank you for watching.